Okay, two things. Here you've got the data left over from the last video. So if you watched my last video introducing remapping, you will have seen that that was on the screen at the time. The other thing, as I move into looking at the smoke map, is an apology because this video may well run and run and run. I'm going to try and keep it as brief as I can, but there's a slight problem with keeping this one brief, and that's simply because it's complicated. Right, okay, here we go. Smoke map. That's the actual map. There's the maximum that we had, 58. Right, now a brief comment that has no pictures, so there's nothing for me to point out apart from this map down here, is to do with stoichiometry or stoichiometry, which in English is the fuel-air ratio or the air-fuel ratio, whichever way around you want to put it. Petrol has a fuel-air ratio of pretty much 14.7 to 1. So one amount of fuel, so 1 gram of fuel, will need 14.7 grams of air to burn. It varies very, very slightly because petrol isn't an individual one chemical, it's a mix of different things. Now, if you make calculations or do experiments with diesel, you pretty much get the same answer. In other words, the value for diesel is pretty much the same as petrol. It usually comes out somewhere around about 14.6. Funnily enough, there's a 14.6 there. So in other words, for diesel, the value that lots of people would quote if they were scientists would be 14.6 to 1. So 1 gram of fuel, 14.6 grams of air. Now, because of the way diesel engines work, that number doesn't really apply, because instead of having a amount of fuel and then sucking in a reasonable amount of air and then burning it by igniting it with a spark plug, diesels don't do that, because a diesel can either suck in a reasonable amount of air, let's say a cylinder's worth, because there's no boost on it, so it sucks in a reasonable amount of air, but then the injector squirts in a preset amount of fuel. So obviously, if somebody is designing a file to do with the amount of fuel to be injected, they need to bear that in mind, don't they? They need to say to themselves, excuse me, I should only be injecting somewhere in the region of 1 gram of fuel per 14.6 grams of air, because that's the amount of fuel that's going to burn happily. Now, of course, they won't want to risk being too close to the exact correct point, because if things are not quite as efficient as they think they're going to be in the engine, what will happen is they will get black smoke coming out of the exhaust. And so the designers deliberately pick a figure which is slightly higher than 14.6. And so what you usually find when you look at these files is you find lots of values somewhere around about 15 or 16. And these figures are usually used by people who do mapping as a base value. So in other words, they're saying to themselves, if I use somewhere around about 15 or 16, I know that with no boost whatsoever, that will be a little bit more air than is required for 1 gram of fuel to burn. So I can inject 1 gram of fuel, and if I use a ratio of 1 to 15 or 1 to 16, and most people would probably go nearer 1 to 16 to be on the safe side, if I inject it at a ratio of 1 to 16, I'll be okay, the engine will run happily, and I won't get smoke coming out the back of the car. So if I'm looking at a map or information on fueling for a car that doesn't have a turbocharger, it would not be surprising to find lots of values somewhere around about 16. That would be a perfectly acceptable value to find. If I'm looking at a car that's got a turbocharger, I will probably find values that operate fairly regularly somewhere up around about 19, 20, 21, 22. So I wouldn't be at all surprised to find values up around in this region, because I'm forcing in more air for the fuel that's going to be available. I can try to run the whole thing a little bit leaner, and so I can force in some more air, because literally I can. I mean, I can force in air, can't I? Because I've got a turbocharger. And diesel engines are perfectly happy with that. They will run perfectly happily on mixtures where a petrol engine would be saying, this is getting too lean and, I'm not happy. So the engine would run not very happily, or it might start to damage the engine because I'm going way too lean. But you can go quite a lot leaner than the agreed chemical stoichiometric value of 14.6, and the diesel engine is perfectly happy with that. Now, this information is of two values in a sense, because if you want to risk having more smoke and pouring more fuel into your engine, then you can stick closer to 14.6, but you risk having loads and loads and loads of black smoke coming out the back of your engine. If you want to tune for economy instead, you could try changing some of these by increasing them a bit more, couldn't you? You could say, well, actually what I would like is to have some figures that are up here but further down there. So what I would like is to consider leaning these off a bit more by making them, let's say, 20 or 21 or something, and seeing how I get with that. Now, where did this come from? Well, this map isn't in Winnows. This is one that I've made up, because basically all I've done is I've taken the number on the smoke map for the amount of air, and I've divided it by the amount of fuel that the designers were injecting at that point. So in other words, this number here is simply that number there divided by that one, and then the next one down is that number divided by that one. So in other words, I've just used the calculators built into Excel to allow me to make a change to that map so that it looks like this, because I wanted to show anybody looking what this means in terms of an air-fuel ratio and what you might like to do with that air-fuel ratio. Now, it might be an idea to consider doing this to every change you make. So it might be an idea, if you are going to change this map, to consider doing what I did with the driver's wish map and rebuilding it over here with some slight percentage changes. But it might also be worth rebuilding this map over here at the same time, so that not only have you got an example of your changes, but you can see what they are doing instantly to the air-fuel ratio. That's entirely up to you. I mean, you may feel you don't want to bother, or you may feel you need to bother. I don't know. I mean, that's entirely up to you, because at first glance, for some people, these figures make perfect sense, and for some people, looking at these figures helps them understand what they're doing. So, but that is entirely up to you. Now, let's do what we did last time. If you were looking at the previous video, let's have a look at making a copy of this one. So let's just have a quick look and say, well, I want that to be that cell. So I'm going to press enter, and then I'm just going to copy that one across. I need to go one more, don't I? So I need to go one more, so I'll just copy that one across. I could do with resetting these columns because they've gone wider, but I don't suppose it will be a problem at the moment. And then I'll go to this one and I'll copy that one down to there. So I've now got that bit and I've got that bit. I'm not going to worry about the title at the moment. And then I'm going to say to myself, like, that equals that, enter, and then I'm going to say to myself, what change shall I make? Now again, where you should be making the changes is a matter of discussion. Most people make changes to these maps only in the performance area, because that's where they want the performance to be different. But again, I'm just going to go for our global one at the moment, so I'm just going to put in there times 1.1 and have my 10% increase. So I'm just going to go and have a 10% increase and see what that does. There we are. Now I could do this forwards or backwards, and if you don't quite understand what I mean is I could have decided to work out what's a suitable percentage instead of just adding 10%. Because what I could have done is I could have worked out what percentage would put 58 up to 70, couldn't I? I could have said, well, how much do I need to increase 58 by to get it to be 70, because I had 70 on the driver's wish, and then I could increase from there. But I'm not going to at the moment. I'm just going to stick with that. Okay, so what I've got now is I've got a maximum of 63.8. So let's go back and do it again. Let's go back to there. Let's go 20% and see what we get. So that's gone up by 20%. I'll go down and have a look at the whole. Oh, hasn't gone all the way. I'll just do that again. Just going to go down. Right, that's gone 20%. I'm going to drag that across. Oh, well, that's pretty much given me my 70, hasn't it? I mean, if I increase by 20%, I end up at 69.6 and 69.4. I could live with that. So I've got figures closer to the maximum sorts of figures that I was thinking of. And now this column has got the sort of maximum figures that the previous column had. So this one has now got the sort of 58-ish numbers, but of course it's got some higher ones that were over here. Now the question in my mind is, should I have changed any of these over here? Should I have changed any at lower values? Now this is again where it doesn't matter a great deal, because I can test that to make up my own mind. I can decide to load this data in to my ECU and test it as it is if I want, or I can decide to only load in the performance corner, as it were, and pick some of this over here and leave the rest as it was. And that's entirely up to me. Lots of people would recommend that you only upload and change the corner for the performance, which of course makes perfect sense, because then your economy will not be affected over here. Now, a word of warning: do not do this and then say to yourself, right, oh, I'll go and try that. Do not do anything with this map unless you've watched more of these videos, which I haven't done yet, but hopefully I will do, because you cannot make these changes in isolation, because you've just, if you followed this, changed the amount of fuel. And you've changed the amount of fuel for the available amount of air up here. But where is the air coming from? If you now redo this fuel-air ratio down here, it's not going to have the same sort of values as it had before, because you've just left the air supply as per original at 1050, but you've got a 20% increase in fuel. So these values are going to dramatically drop. So if you put this data straight into your map, load it up into the ECU and drive, you may well think, wow, this is great, I've got a huge improvement in performance. You may, but you may not. You may have very little increase in performance and massive amounts of black smoke pouring out the back of the exhaust. You will know very quickly by producing this map, and I'm not going to, because it's going to take time, and I don't want people to be completely and utterly bored to death of this. I mean, listening to me is bad enough. So I'm not going to waste time producing all of that on there to show you the figures. If you want to do this, do it yourself with your own version of Excel. But consider that before you do anything else. So do not just say, oh yeah, that'll do, stick it in and off I go. That's not a good idea, because the air needs changing, and the air will need changing via the boost map. And so that will be the next video. The next video will be, hey, I've got a 20% increase in fuel here. Where's the air coming from? So that's going to be the next video.